Hello everyone, welcome back to Husky Math. Today we will be starting application of derivatives, and on it our first topic will be the rate of change of quantities. Many quantities change continuously with time. Derivatives helps us to measure how fast these quantities are changing. So this concept is known as this rate of change of quantities. So in this video we will learn about how to solve such problems using derivatives. Okay, so let's start seeing the questions. Question 1. The radius of a circle is increasing at the rate of 0.7 centimeter per second, and we have to find what is the rate of increase of its circumference. So here's my circle, and as we all know that the circle depends on its radius. The more the radius, the more area and more its circumference. So if this radius is changing at the rate of 0.7 centimeter per second and the radius is increasing, and this is obvious that its circumference and area will also increase. And the question is asking to find at what rate the circumference of this circle will increase if its radius is increasing at 0.7 centimeter per second. Okay, so here the question has given the rate of increase of radius. That means the rate of increase of radius with respect to time is given, that is dr by dt is given as 0.7 centimeter per second. See, looking at the unit also we can conclude that there is centimeter per second. So here this centimeter is given for radius and this second is given for time. So there's a fraction between centimeter and second, and so of course I have written radius over time. So dr over dt is given as 0.7 centimeter per second. And the question is asking to find the rate of increase of the circumference. That means the rate of change of circumference with respect to time. So we have to find dc over dt. So in this type of questions we have to know some formulas, basic formulas from geometry and mensurations. Okay, so as we all know that circumference of the circle is equal to 2 pi r. That means the circumference depends on r. That means the c is a function of r. So here let us differentiate both sides with respect to time. Then we will have ddt of c equals to 2 pi is constant, and differentiating r with respect to time we will get dr over dt. And hence, since we know the value of dr over dt, that is 0.7 in from question, so let us put it here, and on multiplying we will get 1.4 into, and let us put the value of pi, that is 22 over 7, and if I simplify it, it will be 0.2. 7 1s are 7, 7 2s are 14 into 22, and hence my answer will be 4.4. That means the value of dc over dt is coming 4.4, and it's important to write the unit. So here dc over dt has to be written as 4.4. Now let us look at the quantity here. See, there is circumference, and we know that the circumference is a length actually. So here we will be writing centimeter, and per, in denominator we have time, so we will write second. So my final answer will be 4.4 centimeter per second. So here the concept is that if the radius is increasing 0.7 centimeter in 1 second, then the circumference will increase 4.4 centimeter in 1 second. So this was the question, and this is the way how we apply the differentiation. Question number 2. The length of a rectangle is decreasing at the rate of 5 centimeter per minute, and the width is increasing at the rate of 4 centimeter per minute. So obviously there will be change in its area and its perimeter, but we have to find the change in perimeter with respect to time. Okay, so here the question has given there is a change in length with respect to time, that is dl over dt is given 5 centimeter per minute. That means in 1 minute the length is decreasing by 5 centimeter, and since the length is decreasing, so we will be writing here minus, and the width is increasing at the rate of 4 centimeter per minute. That means that there is a change in width with respect to time, and it is increasing, so we will be writing plus only, so it will be 4 centimeter per minute. So in 1 minute the length is decreasing by 5 centimeter, and in that same 1 minute the width is increasing by 4 centimeter, and we have to find the rate of change of its perimeter. That means we have to find the change in perimeter with respect to time. So for this we have to know the formula for the perimeter of a rectangle, and we know that the perimeter of a rectangle is equal to 2 times length plus breadth, or we can write width. So let us differentiate both sides with respect to t, then we will get d dt of p equals to 2 into d dt of L plus d dt of W. And since we know the value of dl over dt, that is minus 5, plus dw by dt is 4, and we will be getting 2 into minus 1, so it will be minus 2. So the change in perimeter with respect to time is minus 2 centimeter in 1 minute. So since the answer is coming in minus, that means the perimeter will also decrease as the time passes. Question number 3. The radius of a circular soap bubble is increasing at the rate of 0.2 centimeter per second. See, here the question is saying there's a circular soap bubble. That means bubble will be in a spherical shape. So here the shape is sphere, and the question has given that the radius of this sphere is increasing at the rate of 0.2 centimeter per second. That means there is a change in radius with respect to time, and it is given as 0.2 centimeter in 1 second. And we have to find the rate of increase of its surface area. Obviously, if the radius of a sphere increases, then its surface area will also increase. So we have to find the rate of change of surface area with respect to time. So we will find ds over dt. So for this, again, we should know the surface area of a sphere, and we know that the surface area of a sphere is equal to 4 pi r square. So here s is a function of r. So let us differentiate both sides with respect to time, then we will get ds over dt equals to, see, 4 pi is constant, no need to differentiate, and we will differentiate d dt of r square. So it will be 4 pi 2r, but using the chain rule there will be dr by dt at last also. Okay, so this equals to 4 2s are 8 pi r into, and we know the value of dr over dt, that is 0.2. So here we will put 0.2, and this will be equal to 1.6 pi r. So this is the value of ds over dt. So we have found the rate of change of surface area with respect to time, that is 1.6 pi into r. But the question is asking to find what will be the surface area when the radius is exactly 7 centimeter. So the change of surface area with respect to time when the radius is exactly 7 centimeter. So we will just put the value 1.6 into, let us put the value of pi also, that is 22 over 7 into, and the radius is 7 here. So this 7 and 7 got cancelled. So here it will be 1.6 into 22, and let us multiply this. We will get 352, and we will put decimal here. So it is 35.2. So the value of ds over dt is 35.2. Now, very important thing to note here is that the unit. Now, since we are calculating the change in surface area and the unit of area is centimeter square, so here we will be writing 35.2 centimeter square per second. So that means if the radius of this circular soap bubble is increasing at the rate of 0.2 centimeter in 1 second, and in that 1 second the rate of change of surface area is 35.2 centimeters square. Question number 4. The bottom of a rectangular swimming tank is 25 meter by 40 meter. Water is pumped into the tank at the rate of 500 cubic meters per minute. Find the rate at which the level of the water in the tank is rising. Here's a rectangular swimming tank, and obviously the shape of a swimming tank will be a cuboid. So first let us make a cuboid. So here's the bottom of the rectangular swimming tank. That means the floor of the tank is 25 meter by 40 meters. So here the length is 25 meter and the width of the base, that is breadth, is 40 meter. And let us assume the height of this tank is h. Now they are pouring water in this tank at the rate of 500 cubic meter, that is 500 meter cube per minute. That means in 1 minute they are putting 500 meter cube of water inside this tank. And looking at the unit, we can say that it is 500 meter cube. See, meter cube is the unit of volume. That means the volume of water is increasing at 500 meter cube in 1 minute. That means the question has given this value as the change of volume with respect to time. And we are asked to find at which rate the level of the water in the tank is rising. That means the level of the water in the tank, that means the height of the water will increase as the water comes inside the tank. So we have to find the at which rate the height of the water tank will increase. That means dH over dt we have to find. Now since water is getting inside the tank, so the water will take the shape of the tank. So the volume of the tank, that means the volume of the cuboid, is length into breadth into height. And since the question has given the length as 25 meter and breadth as 40 meter, so let us put that those values here. Then we will have V equals to 1000 into H. Now let us differentiate both sides with respect to T. Then we will have dV over dt equals to 1000 ddt of H, and we have the value of dV over dt, that is 500 meter cube, equals to 1000 dH over dt. So the value of dH over dt is equal to 500 by 1000. So 20 got cancelled, 5 1s are 5, 5 2s are 10, and hence the value of dH over dt is equal to 1 by 2, that is 0.5. And the unit will be, see, there is a change in height, and height is length only, so 0.5 meter per minute. So if the water is pouring at the rate of 500 meter cube in 1 minute, the height of the water level will increase by 0.5 meter in 1 minute. Question 5. A 2 meter tall man walks at a uniform speed of 5 km per hour away from a 6 meter high lamp post. Find the rate at which the length of his shadow increases. So here's a man, a lamp post, and obviously there will be a shadow of a man on the ground. So let us make a picture. So let this be my lamp post, and let this be our ground, and let a man be standing somewhere over here who is 2 meter tall, and the height of the lamppost is given as 6 meter and the height of a man is given as 2 meter. Now since we know that a ray of light travels in a straight line, so let me first make a ray of light coming from the lamp through the top of the person and making a shadow somewhere over here. So let us name some points here. So let this point be A, this point be B, and let this AB be our lamppost, and let this point be C, and this point be D, and obviously CD is our person, a tall man. Let this point be E. So here obviously we can see that the shadow of the man will be somewhere over here on the ground. This DE is the length of his shadow. So here we will assume the distance between the lamppost and the man as x. This x is the distance between lamppost and the man, and let y be the shadow of this man. See, this DE is his shadow, and I'm assuming the length of the shadow as y, and this x is the distance between the lamppost and the man. Okay, so now let us reread the question. The question was saying that this man is walking with a uniform speed of 5 km per hour away from a high lamp post. If this man is walking away from the lamppost, obviously the distance between the lamppost and the man will increase. That means there is a change in x. Okay, so the 5 km per hour is actually the change in x. And how we write the change in x? We write the change in x with respect to time. So this is given as 5 km per hour. So now obviously if the distance between the man and the lamppost will increase, obviously the length of the shadow will also change. Okay, so here the length of the shadow is y. That means we have to find the change in y. So here we have to find the change in y with respect to time. So I think you are clear with the question. The question has given the value of dx over dt, and we have to find the value of dy over dt. Now in this type of questions, we have to find the relation between this x and y. Until and unless we do not know the relation between x and y, we cannot find the value of dy over dt. So how to find the relation between x and y? We have to create an equation between x and y. So here we will be using one concept from geometry, that is similarity of triangles. As you can see, there is a bigger triangle ABE and a smaller triangle CDE. Now these two triangles are similar. If you ask me how, then let us discuss in short. We see that this particular angle is, that is angle E, is common for both two triangles, and this is 90 degree for the smaller triangle, and angle B is also 90 degree for the bigger triangle. Then obviously the angle C and the angle A will also be equal, and so all three angles of these two triangles are equal. That means these two triangles are similar. So here it is clear that triangle ABE, that is the bigger triangle, is similar to the triangle smaller, that is CDE. And if the two triangles are similar, we know that the ratio of their corresponding sides will also be equal. So if I write the side AB of the bigger triangle, then the corresponding side of it in the smaller triangle is CD, and this will be equal to the side BE of the bigger triangle is corresponding to the side DE of a smaller triangle, and of course it will be equal to the side AE of bigger triangle to the side CE of smaller triangle. Okay, now let us put the values here. Then we will have the value of AB is 6 meter, the value of CD is 2 meter, the value of BE. So looking at the figure, can you tell me the value of BE? The distance BE is x plus y. So here we will be writing x plus y over the value of DE from the figure is y. Now I will be not using the third ratio, because with these two ratios only I am getting the relation between x and y. My aim was to form an equation between x and y, which is going to be here. So here first let us cancel. 2 1 is 2, 2 3 is 6. So here it will be x plus y equals to 3y, and hence x will be equal to 3y minus y is 2y. Now since we have got an equation between x and y, now we will differentiate both sides with respect to t. So differentiating both sides with respect to t, then we will have dx by dt equals to 2 into dy over dt. And since we know the value of dx over dt that is given in question is 5, so this will be equal to 5 equals to 2 into dy over dt, and hence the value of dy over dt equals to 5 by 2, and this is equal to 2.5, and hence we have got the value of dy over dt, and obviously the unit will be kilometer per hour only, because the y is also the length of the shadow, and length is kilometer and time is hour. Okay, that means if this person walks with speed of 5 km per hour away from the lamppost, his shadow will increase at the rate of 2.5 kilometer per hour. So this was our question. Question 6. Water is dripping through a tiny hole at the vertex in the bottom of a conical funnel at a uniform rate of 4 centimeter cube per second. Okay, so there is a conical funnel and the vertex is at the bottom. So first let us make a conical funnel. So here's our conical funnel ready, which is upside down. And the question is saying that water is dripping. That means water is coming out through a tiny hole at the vertex here. Okay, and the rate of water dripping is given as 4 centimeter cube per second. That means obviously if the water is coming out of the conical funnel, that means the volume of the water is decreasing at the rate of 4 centimeter cube per second. That means this is dV over dt. So here you can use the minus sign also. Okay, this is not a big problem. Let us continue reading the question. When the slant height of the water is 3 centimeter, find the rate of decrease of slant height of the water given that the vertical angle of the funnel is 120 degree. Okay, so first of all, there are three variables associated with this cone, that is the radius of the cone, and let us assume it as r. The main height of the cone, let us assume it as h, and the slant height of the cone as L. And obviously we know that this angle will be here 90 degree. Okay, and the question is saying that the vertical angle of the funnel is 120 degree. So here the vertical angle means this angle. The angle at the vertex is 120 degree. And assuming this cone to be a right circular, if this vertical angle is 120 degree, then the half of this angle, that means this particular angle, will be 60 degree here. Okay, so using all this information, let us find the decrease of the slant height of the water. So the decrease of slant height of the water, that means the change of slant height with respect to time. That means we have to find the change in slant height with respect to time. So that means we have to find the value of dl over dt. Since the volume of right circular cone is 1 by 3 pi r square h, so let us differentiate both sides with respect to t, then we will get dv over dt equals to 1 by 3 pi d dt of r square h. Now if you see that there is a right angle triangle inside this cone, okay, and there's a 90 degree here, that means the side opposite to 90 degree, that is L, is hypotenuse here. If we consider this 60 degree, then the side opposite to the 60 degree will be our perpendicular, and obviously the base is the remaining side, that is height. Okay, since we have the perpendicular, base and hypotenuse in this triangle, if I try to find the value of sine 60 degree, then it will be, we know that sine is perpendicular over hypotenuse. So sine 60 degree will be, see the perpendicular here is r and hypotenuse is L. So this implies the value of sine 60 degree is root 3 over 2 equals to r over L, and hence the value of r equals to root 3 by 2 L. See, what we are trying to do is that we are trying to replace this r in terms of L and replace this h in terms of L. Now since we have got the value of r as root 3 by 2 into L, we will put it here. And the value of dv dt is also given, that is the change of volume is given as 4 equals to 1 by 3 pi d dt of r square. The value of r is root 3 by 2 L, so here it will be root 3 by 2 L whole square into h. Now we will try to find the value of h using the same right angle triangle over here. So in this right angle triangle, if I try to find the value of cos 60 degree, so here in this triangle, if I try to find the value of cos 60 degree, then we know that cos is base over hypotenuse, and the value of cos is 1 by 2, and this equals to, now my base is h, the height of the cone, and the hypotenuse is our slant height. So here the value of h equals to L by 2. Now we will put this value of h here in this equation. So here it will be L by 2. Now since we have replaced r and h in terms of L, now we will differentiate. So here it will be 4 equals to 1 by 3 pi d dt of root 3 square is 3, 2 square is 4, L square into L by 2. So here this 3 and 3 got cancelled. Now let us take the constant terms outside the differentiation. Then we will have pi over in denominator, that is 4 into 2, that is 8, and we will differentiate d dt of L square into L is L cube. This implies 4 equals to pi over 8 into d dt of L cube is 3L square into dl over dt using the chain rule. So on cross multiplying we will get dl over dt equals to 32 by 3 pi L square. So we have got the change of slant height with respect to time, but the question is asking to find this value when the slant height of the water is 3 centimeter. That means we will put the value of L as 3 centimeter. So this implies dl over dt when the value of L equals to 3 will be equal to 32 by 3 into pi into 3 square. So this equals to 32 by 3 square is 9, 9 3s are 27 pi. So you can put the value of pi here, or you can keep it like this only. So now let us write the unit. So this is the change of slant height with respect to time, and since slant height is our length only, so here it will be centimeter per second. Question number 7. A 13-meter long ladder is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 meters per second. How fast is its height on the wall decreasing when the foot of the ladder is 5 meters away from the wall? So there's a ladder leaning against the wall. So let us make a wall and a ground where our ladder is leaning against the wall. So let this point be A, B and C. Obviously we will assume the wall to be 90 degrees with the ground. Let AC be our ladder, and the length of the ladder is 13 meters, which is given. Okay. Now the question is saying that if I pull, that means if I pull the ladder from the bottom away from the ground, then of course the top of the ladder will come down against the wall. That means the height of the top of the ladder from the ground will decrease if we pull the bottom of the ladder along the ground and away from the wall. So here let me make another picture. Here let us assume this picture, these two pictures as before and after. So before it was leaning against the wall and against the wall at a certain height. Now the height of the top of the ladder has decreased because the bottom of the ladder has been pulled away from the bottom, away from the wall. But still the length of the ladder will be 13 meters only. So here let us assume this height of the top of the ladder from the ground be x, and let us assume the distance between the ladder, the bottom of the ladder and the wall be y. So here the question has given this wall has been pulled along the ground away from the wall at the rate of 2 meters per second. That means there will be the change in y if the bottom of the ladder will be pulled. Okay, so the question has given the change in y with respect to time, and that is 2 meters per second. And we have to find how fast its height on the wall is decreasing. That means the height of the top of the ladder on the wall is decreasing. That means we have to find the change in x with respect to time. So we have to find dx by dt. Also the question has given when the foot of the ladder is 5 meters away from the wall. So if the foot of the ladder is 5 meters away from the wall, that means if this distance is known, then we can obviously find the height of the top of the ladder from the ground. That means we can always find this. Okay, so first let us find this height of the ladder from the ground using Pythagoras theorem. So the perpendicular square plus base is 5 square will be equal to hypotenuse square. So here it will be p square equals to 13 square is 169 minus 5 square is 25, and hence p square will be 144, and the value of p will be square root of 144, and that will be 12. So here we will be taking positive because the height cannot be negative. That means height of the ladder from the ground will be 12 meter when the foot of the ladder is 5 meter away from the wall. Okay, so this information we know here. Now let us come back to the earlier picture where we have to find the value of dx over dt, and again I said that there should be some relation between x and y. Only that time we can find the value of dx over dt. Okay, so now how to establish the relation between x and y? It's simple. It's very simple as that, because this is again a right angle triangle. So using Pythagoras theorem here, we can write that perpendicular square, that is x square plus base square, is equal to hypotenuse square. So let us differentiate both sides with respect to t. Then we will have d dt of x square plus d dt of y square equals to d dt of 13 square is 0 as it is a constant. So this implies 2x dx by dt plus 2y dy over dt equals to 0. Now let us put the values which we know. So here it will be 2 into the value of x. See, when the value of y is 5 meter, say this distance is y, because the distance of the foot of the ladder is given as 5 meter, then the height of the ladder will be 12 meter. That means this is the value of x. So here we will be writing 2 into 12 into dx over dt plus 2 into the value of y is we can put as 5 into, and dy by dt is also given as 2 meter per second. So we will put here 2 equals to 0. So let us simplify. It will be 24 dx over dt plus 2 5s are 10, 10 2s are 20 equals to 0, and the value of dx over dt will be equal to minus 20 over 24. So here it will be 4 5s are 20, 4 6 are 24. So this implies dx over dt equals to minus 5 over 6. So the unit will be meter per second, because this is the change in x, that is height of the ladder on the wall with respect to time. And since the answer is coming in negative, that means the height will obviously decrease if we pull the ladder along the ground from the bottom. Question number 8, and this would be the last question of this particular topic. At what points the ellipse 16x square plus 9y square equals to 400 does the ordinate decrease at the same rate at which the abscissa increases? Okay, the question is asking to find the points. So in a coordinate geometry, we know the first element is known as abscissa, and the second element is known as ordinate. So the question is saying that the ordinate decreases. So here the rate of change of ordinate is dy over dt, and the question is saying that it is decreasing. That means there should be minus here, and at which rate? At the same rate at which the abscissa increases. So the rate of change of abscissa is dx over dt. So this is the information that question has given, that is dy over dt equals to minus dx over dt. So let us again see it here. This is the change in ordinate with respect to time, and it is equal to the change in abscissa with respect to time, but the ordinate is decreasing and the abscissa is increasing. So that's why there is a minus sign here, because ordinate is decreasing. So this is the information the question has given, and the equation of the ellipse is also given. So now let us differentiate the given equation with respect to time. So the equation of the ellipse is given as 16x square plus 9y square equals to 400. let us differentiate both sides with respect to t. Then we will have d dt of x square plus 9 into d dt of y square equals to d dt of 400 is 0. So here it will be 16 into 2x dx over dt plus 9 into 2y into dy over dt equals to 0. Now 16 2s are 32x dx over dt plus 18y. Let us put the value of dy over dt as minus dx over dt equals to 0. This implies 32x dx over dt minus 18y dx over dt equals to 0. Let us take out dx over dt, this is t, common, then it will be 32x minus 18y dx over dt equals to 0. Now here one thing we have to note, that the question is saying that the abscissa is increasing. That means there must be some change. That means this change cannot be 0. That means the other expression, that is 32x minus 18y, should be 0. So here it will be 32x minus 18y equals to 0. Implies 32x equals to 18y, and hence the value of y can be written as 32 by 18x. So it will be 2 16s are 32, 2 9s are 18, x equals to y. So let this be equation 1, and let us put the value of this y in the given equation of the ellipse. So my equation of the ellipse is 16x square plus 9y square equals to 400. So this implies 16x square plus 9 into, see the value of y we have just got in equation 1 is 16 by 9x. So let us put it here. So it will be 16 by 9x whole square equals to 400. So here it will be 16x square plus 9 into 16 square is 256 x square by 9 square. This 9 and this square got cancelled, equals to 400. Now let us take the LCM. Then we will have 9 9 6 are 54, 9 1 are 9, 10 11 12 13 14. So it is 144 x square plus 256 x square equals to 400. This implies if we add the numerator term, then it will be 400 x square equals to 9 into 400, and this 400 got cancelled, and hence the value of x is plus minus square root of 9, and hence the value of x is equal to plus minus of 3. So since we have got the two values of y, now let us put this in equation 1, and let us get the value of y also. Now when x equals to 3, then y equals to 16 into 3 by 9. 3 1 is 3, 3 3 is 9. So the value of y is 16 by 3. And if the value of x is minus 3, then obviously y will be minus 16 by 3. And hence the question was asking to find the points, at what points of the ellipse. So my points are 2, and those 2 points are 3 comma 16 by 3 and minus 3 comma minus 16 by 3.